Hi, I'm Julian, and thank you for joining us today. A brief introduction to Polestar, our background, and who we work with for those of you who don't know us yet. We've been in business over 20 years, and in that time I've worked on both sides of the OT-IT divide, happily working with enterprise IT as well as production engineering. Our core focus is professional and managed services for clients looking to digitise existing production facilities or to build new ones, and we do this globally. As an industrial network integrator, we work across the supply chain with machine builders and OEMs such as Siemens and Fanuc. We've also worked for a long time with IT vendors such as Siemens, Cisco and Microsoft. And we also work in partnership with specialist OT companies like Dispel and Nozomi on industrial cybersecurity projects. In the industrial data space, manufacturing is seeing the biggest increase in demand for new technology. It's also the biggest challenge for us to manage in many ways, as the number of assets in a single factory can range from hundreds to thousands, co-located in a very small geographic area. The challenge for our customers is how to realise the benefits of new technology across operations, innovations, and end customer experience. New OT software and services present an adoption challenge for businesses with a huge range of competing technologies. For example, some of these will promise to deliver X-ray visibility across your production systems. But even if you might know where to start implementing them, it's not always going to be a smooth journey to get to where you might want to end up. Our approach is that you should always remember the needs of the business first and foremost. And secondly, cybersecurity is a process and not a product, and it should be baked in from the ground upwards. Policies are excellent ways to begin that process and provide a cookie-cutter approach to implementation at scale. So how to start? From the technology perspective, there are many levels of maturity on the way to connected factories, smart factories or Industry 4.0, and these terms mean different things to different people, but essentially it's digital transformation for manufacturing companies, or more precisely, industrial IoT, digital twins, cyber physical systems. And companies can take advantage of all three, but you need to implement them successfully in the order shown 1 to 5. So you can realise the fully automated future. Many companies have been dipping their toes in the water with proof of concepts for data analytics, and it's not easy to introduce control systems later on in the process. So you need to think of Industry 4.0 almost as if it's a closed loop. And we break these stages down into 5 steps for successful adoption. Basic computerization, connectivity and environmental. Secure integration of OT and IT layers and all departments. Engineering, production, manufacturing, IT, security. Connected machines, maybe with additional sensors for visibility, leading to a digital module of the factory to show what's happening at any given time. And that allows for the upkeep of the digital twin model at all times. Gathering the right data transparently and in quantities sufficient for meaningful analysis, which is the primary requirement for predictive maintenance. And finally, smart simulation of different future scenarios and identification of the most likely ones, allowing for accurate decision making and implementation of appropriate and timely measures. Eventually, this will be without human assistance in order to get the best results in the shortest possible time through tools like AI. The Independent Made Smarter review in 2017, off the back of the UK government's industrial strategy paper, summarised what the major issues are for a lot of manufacturers, and we see these issues not only on the factory floor but through the entire business, including the boardroom. And the primary key challenges identified were leadership and governance, who, what, where and why. OT is not the sole responsibility of CISOs, CTOs, CPOs, production directors, it's all of them. Upskilling, new skills need to be learnt by existing teams and staff need to be retrained. However, on the plus side, training makes the systems easier to use and understand while reducing complexity or perception of complexity. And adoption, lack of the right standards and too many superfluous standards across the business units creates paralysis and prevents the adoption of industrial digital technologies. And the great thing about standards, there are so many to choose from. One of the biggest barriers to adoption that we hear is in talking with customers is concerns over cybersecurity through frameworks like IEC 62443 and NIST directive now go a long way to providing some help and guidance. The end goal was to get to the following outcomes: design, plan and implement a secure, highly available OT network in order to reduce downtime and increase operational efficiency, which were the core requirements. Define and then apply the logical ownership of the various layers of the OT networks and systems by planning and appointing responsible owners where there are currently gaps or duplication of roles. Allowing automation and other teams to focus on the core business, and this will help link the company strategy and objectives to production practice, e.g. standardising change processes and forms to be used for the rollout of new services and applications. Producing guidelines and recommendations for global network design, and a standardised catalogue of hardware and software vendors and services and products for production facilities across multiple sites and countries. Defining the key service delivery and service levels required for plant operation, e.g. maintenance and support, change management, internal and external. Providing greater visibility of the production system and events, which will assist with integration projects on brownfield sites and inform future policy for new greenfield sites. And finally, spend less time firefighting. Some of the sections that we produce: physical infrastructures, logical network topologies, implementation guidelines, in-life maintenance and support, and also a specific section on control systems where we go into detail with PLC software development, safety controls, alarms, and even using the Semantic Control Security tool.